now I'm going to explain you how we inject relevant memories. We actually do this thing by using this framework or this concept called Retrieval Augmented Generation. And by explaining you this, along the way, I'm going to explain you, and you're going to understand super well what is an embedding, what is an embedding model, what is semantic search, and what is a vector database. So let's get started. So Retrieval Augmented Generation is a 3-word concept. And as a 3-word concept, I want you to understand it as a 3-step process. So first of all, retrieve, second, augment, and third, generate. And let's start now by, of course, number 1, retrieve. So what happens when Ava gives you an answer is injecting some relevant memories before giving you the answer, right? So those memories will be injected, let's say, in the prompt. So those memories that we retrieve are the result of doing something called semantic search. And now let's go step by step to understand how we do this semantic search and what it actually represents, what it actually means. So first of all, we have just a query or a question or just a sentence that is just a string, right? It's just plain text. So what we do is we use an embedding model to generate an embedding or an embedding vector, which is simply a vector representation of an object, text, image, video, or audio. And by vector representation, we just say numerical representation, right? As we have it here, it could be something like 0.5, 0.4, 0.8, 0.1. And usually, of course, in a higher dimensionality than just 4, but essentially it's just that, right? It's just a vector, so a numerical vector. So what is an embedding model then? So an embedding model is a model that converts those objects into meaningful vector representations. And here let's pay attention to meaningful. And by meaningful, let's understand it from the text perspective. So it has a semantic meaning, right? And this concept of semantic meaning ties very well with the next thing, which is semantic search. So semantic search is just doing kind of like nearest neighbors for vector representations. And nearest neighbor, if you don't know, is a technique to find those close elements in regards to a distance. And finally, last thing from this list, what is a vector database then? So a vector database is also called like a vector search engine. And that what it does is it manages, so it helps you indexing, retrieving, and querying these embedding vectors. And since I know this might still not be completely clear, let's zoom in what a vector database is. Right? So a vector database would store these high-dimensional vectors, but now for the sake of this explanation, let's just imagine that we have just 2 dimensions. And what I have here represented in green are those relevant memories that we have already extracted in past conversations with the user. And in blue, we have that query for which we are doing the semantic search. So what we are actually doing is finding in this high-dimensional space, so here in this simplified version, in this 2-dimensional space, those vectors that are the closest to the query. So here the query was that I could be asking Ava, right? So I could be saying, hey, remember my favorite movie? And Ava, before giving an answer, it will look into her long-term memory, into the vector database, and it would retrieve those relevant memories. So what could be those? Those that have a similar semantic meaning. So let's just look at this sentence, right? We have remember my favorite movie. So what are the things here that have semantic weight? So that would be, for example, remembering, favorite, or movie, right? So here we can see on movie. Movie and film are semantically close because those represent the same thing. And similarly, as well here, movie and movie, of course, that's even clear. And those things are, so these vectors are very close by because they are talking essentially about the same thing, movies. So this way you could imagine also different clusters or different agrupations forming by different topics. So another topic could be something about food. So we have here that Ava has stored in her memory that the user loves pizza and also he likes to eat healthy. Could be contradicting, but here those things are about eating, right? So they are close by in the vector space. Same thing, he's from Lanzarote, he lives in Madrid. So these things could be related to related to a space or to cities, and those things are more. So these two things have more things in common than pizza and Lanzarote. So this more or less would be the whole idea of semantic search. I hope you understood it, and if you didn't understand it, please drop me a comment below, and I'll try to explain it myself. So I'll try to give you more examples, and maybe I can even just send you a couple of articles that explain this as well. So with that, we have understood the first column, or the first part, the retrieve part, which is actually the only complicated part, because the augment and generate parts are very simple. You will see. So by augment, what we mean is just that once we have retrieved this memory, so the closest one was his favorite movie is Ex Machina, we are going to inject that in the prompt along with the current conversation and those system instructions that Ava or the agent is following. And finally, once we have this complete prompt, what we do is just to invoke a large language model. In our case, in the case of Ava, we are using Llama 3.3 via Grok, and we just invoke this model to generate an answer. And the answer could be something like Ex Machina, right? So this shows how we use this framework, RAG, Retrieval Augmented Generation, to inject the relevant memories into Ava's brain. So let's review that again, right? So we take a query like remember my favorite movie. We use an embedding model to generate an embedding. And then we use a technique called semantic search to look in the vector database for those embeddings that are similar semantically. We extract those, or we retrieve those. In this case, could be something like his favorite movie is Ex Machina. Then we augment, right? We inject this into the prompt. And then we use now with all this information, we call a LLM model to give you an answer, which is something like Ex Machina, right? Awesome. So this would more or less represent a retrieval augmented generation, right? But there are other advanced things that I want to just quickly mention, right? Which is this thing or this word called chunking that you might have heard before. And the whole idea of chunking is that so in this case, in the case of memories, we usually have short sentences or short messages. But what happens when you want to create a vector database based on books, for example, or long pieces of text? So the whole idea is that you have to divide or chunk those long texts into shorter chunks. So that would be chunking. And also an embedding model, right? So in the same way that we have a model for generation, we also have a model for embedding. And here you should select an embedding model depending on more or less depending on that meaningful representation that you want to get from the data, right? So an example could be, for example, if you are talking in a very specific language, right? If you're talking in English, then it's simple, but maybe in Spanish, there are models that work better than others. So you would maybe use an embedding model that is better for only Spanish or for a multilingual application. So that could be an example. Another example could be if you are building a RAG for a very specific domain, for example, biology or chemistry, right? So where you have all these technical words, and maybe if you use a generic embedding model, those would be diluted. So you want a model that is able to find that meaningful representation between those sentences and terms. And if you want a more detailed video about these advanced techniques and just RAG in general, just let me know in the comments and I'll make it.